For today's software engineering interview, we'd like you to design the backend for a multiplayer online game like Clash Royale. The core functionality of the game will be run on a C++ server which handles the game state. I've chosen C++ because it gives us total control over memory and it's also extremely performant. When players take actions or things change on the server side, we'll send out updates to both clients every 30 milliseconds. The server will be the authoritative source of truth for everything about the game. Why don't you have a database? Because games are short-lived, we don't actually need a database here. Whatever virtual machine is running this can store the current game state information in memory so we can have extremely low latency lookups and updates. At the end of the game, we could write the state to some other database, or a different service could handle things like who won, who lost, and how that affects the player's ranking. Okay, and how are the players connected to that server? The players will be connected to the server via WebSockets. We're using WebSockets for extremely low latency bidirectional communication. Bidirectional communication here is needed because the client needs to be able to send something to the server, and the server needs to be able to send something to another client. Now, the server is also responsible for 100% validation of all actions taken to prevent cheating by either of the clients. Looks good, but how can we scale up to more users? Our application is already Dockerized, so we can easily scale horizontally and add more game servers to pick up more traffic using Kubernetes. There's an open source library called Agonies, which is meant for this exact purpose, using Kubernetes on top of multiplayer games.